Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. This episode is brought to you by Acryl Data, the company behind DataHub, the leading developer-friendly data catalog for the modern data stack. Open source DataHub is running in production at several companies like Peloton, Optum, Udemy, Zynga, and others. Acryl Data provides DataHub as an easy-to-consume SaaS product, which has been adopted by several companies. Sign up for the SaaS today at dataengineeringpodcast.com/Acryl. That's ACRYL. Your host is Tobias Macey, and today I'm interviewing Francisco Alberini and May Tao about patterns and practices for incident management in data teams. So, Francisco, can you start by introducing yourself?
Hi, thanks so much, Tobias, for having us here today. So I joined Monte Carlo last year. I was our first product hire here on the team. Prior to that, I spent 5.5 years at Segment, where I started on the success side and spent a couple of years as a PM focused on protocols, which was the data quality management tool for Segment. And yeah, I'm just thrilled to be able to be here today to talk about the things we've learned from our conversations over the last year with data engineers.
And May, how about yourself?
Hi, my name is May. I am the second product hire at Monte Carlo, joined the company in August last year. I actually have a statistics background. My first job in life was writing Python codes for the Berkeley stats department for the research projects. Deviated a little bit and went into, banking and investing before I found my way back to being a data platform manager at a logistic tech startup right before Monte Carlo. That's where I've experienced a whole series of ping of data engineering teams and was exploring potential solutions and discovered Monte Carlo, and the rest is history.
Going back to you, Francisco, do you remember how you got involved in working in the area of data?
Yeah, so a lot of it started when I joined Segment, actually. One of the first projects that I was, assigned as a success engineer was a huge migration across multiple Redshift clusters for our customers. So we basically had the solution where we would stand up Redshift clusters for our customers and basically host the data on their behalf. And we did a huge migration multiple times for our customers across different Redshift clusters and then ultimately to self-hosted version. So that was one of my first introductions to the deep world of data, a lot of dual screening, looking row by row type of spot checking of data. And then as I spent more time at Segment, a lot more interaction with customers and how they use data, how they actually set up the data collection piece and making sure that that was of high quality. And then, of course, down to the warehouse level. So, yeah, that was my introduction.
And May, you mentioned a little bit about how you first got started working in the space of data. I'm curious what it is about this problem domain that keeps you interested.
So at my last company, I actually went through the process of, having our platform as a batch process data stack into real-time streaming, because we were providing logistics solutions to these big shippers that are really dependent on our timely updates of the status of shipments. Gone through the whole process of moving to real-time streaming and also went through a lot of migrations. And I realized my data engineering teams were actually spending a lot of time firefighting and responding to the requests from the execs team, from the BI team, from the operations team. I wasn't really able to focus a lot of their productive time on actually building, our real-time streaming platform, building our price experimentation platform. Started looking into, what are some of the solutions that we can actually deploy, and found these emerging trends of ETL tools, reverse ETL tools, observability solutions, and found it fascinating. And eventually jumped to, the vendor side and devoting my life to building some of these solutions.
You mentioned that you've each had some experience working with customers and also, I'm sure, being on the operator side of these different types of data incidents. And I'm wondering if you can just start by describing some of the ways that an incident in the context of a data system might manifest and possibly some of the differences to incident management that folks from the application development side might be familiar with.
Yeah, I would say the main difference is that in addition to, the common causes in the software engineering or application engineering world, where you have issues that emerge from code changes as well as operational environment issues, in the data world, you have this additional source of quality problems coming from just data issues themselves. So that creates more complexity and more trickiness around resolving some of these like data issues. So to drill a little bit deeper in that, operational issues that we see in the data infra world, a lot of it is like a pipeline failure, like a Airflow DAC that was failing to run because of permission issues, or dbt job failure, or any of these, perhaps like a Google Cloud Function pipeline that your team set up to run some of these pipelines. Any hiccups in that resulting in downstream tables not populating. So that's on the operational side. It could also be code issues that occurs that has to do with the query code themselves. So maybe in your dbt model, you added a limit 500, which resulted in number of rows downstream significantly reduced. The last area is the data issues, which are the trickiest because it could either be a data quality problems that, there's high percentage of null in your values, or it could be, actual changes in your business environment. So like a really common one that we see is schema changes. If you change the column type from string to an integer, that can break some code that generate, the downstream tables. Also get one-time events, like perhaps your marketing team is running a marketing campaign, which results in a lot of changes in traffic data and distribution of channels data that resulted a lot of your detectors firing off and distribution of your downstream table completely shift. So these are some of the most common issues that we've seen that result in data downtime.
Do you have anything to add, Francisco?
No, yeah, I think that covers it. Just those three buckets we found in our conversations really account for the majority of what we call incidents or data incidents. And we really built our platform around those three buckets in a way to understand like what kind of an incident this is, and then how do I very quickly address it. But I think we'll get more into that as we go through.
Yeah, and to the point of resolution at a high level, before we get into more of the details later, what are kind of the various steps involved or the stages of an incident and the different participants that are necessary to be able to bring an incident from I have a problem to I have resolved it?
So I think that the first one is actually getting notified about the incident. And there are many ways to get notified about an incident. The most common one that we've heard is you hear about a downstream consumer that says this number looks weird. Why? That's usually not the best way that you want to get notified about an incident. So a lot of what we've been seeing in the market is just like this idea of automated anomaly detection, which takes the idea of getting notified something by an actual consumer and actually getting notified by a system that's looking for actual issues. So step one is get notified. And then I think from there, the next step that we like to really focus on is actually understanding the impact of an incident. So is this really bad? Should I, get out of bed right now to go fix this incident, or can I wait until tomorrow? Or does no one care? And then in that case, I can just kind of leave it alone and go about doing more impactful work. So I think understanding in terms of the stakeholders there is who are the downstream consumers of this data? Is there anyone consuming the data? And if so, then making a judgment call about the impact. After the impact, understanding the root cause. So let's say you do say, yeah, this is actually a real issue. I'm going to go notify the people that are going to be impacted by this. I next want to actually investigate the root cause. So that's kind of the third phase. To do that, there's lots of things you can do. A lot of times what we hear from customers is they then just go to all the different systems where something could have broken. So they go Airflow, check the logs, they start querying the warehouse to understand the actual more detailed version of what is actually happening in the data. Are there any type of correlations across other fields? Maybe it's a marketing campaign that ran, which caused this issue. Maybe it's something else. And then, of course, understanding upstream, are there any issues? Like, was there a recent schema change that occurred? So we can look at something like lineage for that. After we've come to the point of understanding our root cause, we try and resolve it. We may need to rerun some tasks, backfill data, update code if we need to, whatever it may be, and then notify after that downstream users that this issue has been resolved. And the last piece, which is often forgotten, is the idea of documenting the postmortem of what actually happened so that the next time we can avoid it. Those are the general kind of high-level phases that we see resolution or incident resolution going through.
From a sort of broad level and from your perspective as a vendor that is working in this space of being able to help teams identify when they have an issue, What are you seeing as the general rate of adoption of some of these incident management practices among data teams as compared to application teams, maybe even within the same organization?
It really varies, which I think is probably the obvious answer. I was giving it some thought before, and I think I could kind of summarize it. There's like three real core types of teams that we're seeing in terms of how customers are adopting these different principles and kind of how much they're investing. And I've come up with some fancy names for them. But the first one is the idea of like the goal. I don't know if you ever read Eliyahu Goldratt's book. It's called The Goal, and it's all about operational efficiency. So it's like defining these really, really crisp processes so that you're continually improving the efficiency of the system overall. And we have a bunch of customers that fall into that they're just so heavily invested in the process. And we can see a lot of value in that. Like it's actually really producing a ton of value for the company. Especially important for bigger teams that have lots of stakeholders. They have distributed teams focused on different parts of the stack, thinking about how data mesh fits on top of that. One of our customers, Red Ventures, his name is Brandon Bidell, and he's kind of like the perfect example of this. We just released a blog post with him, but he's just done so much to define processes and get everyone aligned around what are the SLAs, who takes ownership of an incident, who should be the responsible party, how do we make sure that issue is addressed and that it's communicated to the organization, all of those questions. So that's the first one. And the second one is what I call the boss mode team. And these are usually smaller data teams, and they're less focused on process because for the most part, any person on that team probably has the entire data pipeline in their head. And I've actually was talking to a customer recently, and I was telling him or asking him, like, how do you think about incident resolution? And he basically said, like, listen, I've been here for 4 years. Like, I could probably tell you when I see an incident, what line of code is like causing that. What is actually causing that particular incident from happening? So like for me, it's very easy to then go and resolve the issue. Like I know exactly what to do. And not that this person was, super full of themselves. Like it was a humble representation of reality, and that like, I don't need to spend a lot of time investing in process because I can fix things really quickly. What's more important is that I get notified of an issue very quickly. Like that's what I want. I want to get notified as soon as something happens so that I can go fix it. And then the last one is more of like these teams that have a lot of breadth and not a ton of resourcing. So by breadth, I mean like in the hundreds of thousands of tables that they're trying to manage and think about how do we improve the quality of this system. So they could develop a lot of process, but the reality is that's going to require a lot of resourcing. So they need to have a ton of team members, they need to find all this process. So the kind of slight variation there is they're thinking more about how do we kind of reduce the complexity of what we've built here or what's been built over time. All these tables that no one's using, how do I remove them? So that kind of reduces the scope of what is we're responsible for. How do I quantify the complexity of our pipelines today? So then I can present that to our leadership and say, how do we reduce this complexity? And we have a bunch of customers that are thinking about it that way. Hopefully that's a helpful representation of the kind of teams and how we're seeing some of the trends there.
Definitely. And in terms of the organizations that do have more process in place where you don't necessarily have one or a few people on the team who know everything about everything in the data platform because of the sort of relatively small scope or the relatively long tenure of the people, when you do have to start introducing more process and practices and formalities around incident management, what are some of the sort of organizational and technical challenges that those teams have to deal with as they start to define and implement those practices?
Actually, one example that comes to mind is how do you structure the team in a way that it's clear who's responsible for what? So when incidents happen, there's clear ownership of who should go and fix it. So one of our customer that is an online marketplace company, they have this data mesh architecture, and they structure their team around domains. So they have a team that's responsible for the marketing data, a team responsible for finance data, and another team responsible for their customer service data. And they have a data engineer and a data analyst, each responsible for each area. So when there are data issues that happen, they know that if it's like a freshness of volume type of issue, it's the data engineer that's responsible for looking into it. If there is an field distribution type of issues, then it's the data analyst's job to take ownership over that issue. So that's like kind of how they structure their organizational structure to respond to increasing number of data issues that are happening and streamline their workflow.
Are you looking for a structured and battle-tested approach for learning data engineering? Would you like to know how you can build proper data infrastructures that are built to last? Would you like to have a seasoned industry expert guide you and answer all of your questions? Join Pipeline Academy, the world's first data engineering bootcamp. Learn in small groups with like-minded professionals for 9 weeks part-time to level up in your career. The course covers the most relevant and essential data and software engineering topics that enable you to start your journey as a professional data engineer or analytics engineer. Plus, they have Ask Me Anythings with world-class guest speakers every week. The next cohort starts in April of 2022. Visit dataengineeringpodcast.com/academy today and apply now. And then one of the perennial challenges of any sort of alerting or incident identification and management is one for the problem of alert fatigue and making sure you don't have too many signals that drown out or too much information that drowns out the signal. And then the other question is just what are the actual signals that you need to be worried about, or what are the sources of information that are going to carry the most weight for you to be able to identify that I actually have a problem here versus just here's some additional information and context that maybe is useful when you're digging into the problem, but isn't going to tell you whether or not you have an actual issue. And just some of the ways that data teams need to be thinking about at what points of their system they need to introduce these monitors and the methods that they use for being able to send and notify on those pieces of information.
I kind of think of it as the leading signals and the lagging signals. You really don't want to have any lagging signals, which are usually the downstream data consumers, seeing a broken report and come to you and be like, can you fix it? Or the data products that you have are experiencing data quality issues and resurfacing back to the data engineering teams. Or also already a lagging signal is that if your data teams are already spending, 20-30% of their time, similar to my old data team, trying to firefight these data issues, instead of being able to spend the time on revenue generating features like improving your experimentation platform and improving your streaming platform. Those are the probably already late signs of you should investing into, building some monitoring system and getting real-time alerts. And some of the earlier signs could be your data sets, size of the number of tables you have already growing over a certain size. More than 50 tables is already a significant size for you to warrant some kind of monitoring on top, or your complexity of data stack, a number of data sources that you have, the variety of data sources you have, how often your data sources are changing, or the number of data pipelines that you have set up feeding your tables. And then the last one is somewhat more obvious of the size of your data engineering team. Initially, when you probably have like 1 or 2 people, you can coordinate among yourself and have clear ownership of who's monitoring what. When you grow to a little bit bigger than that, if you have like 5 people in your data engineering team, that's usually a sign of teams growing large enough that more automation and system in place to ensure data quality. And on the other side, the consumer side, if the number of your data consumers, which can include anyone from the BI team to your financial analyst, marketing analyst, data exec team, is growing over time, that's also a sign when you should start building the initial building blocks for this monitoring system.
In terms of the actual alerting aspect of it, it's definitely very sort of subjective and based on the context and capabilities of the team, and can be nuanced depending on those leading and lagging indicators and sort of what are the highest value signals that you're capturing. And I'm curious what you see as some of the useful practices for being able to introduce alerting to a data team or an organization that has some level of data capacity, and being able to build feedback loops to understand which alerts are useful, how to tune those alerts, understanding when you actually just need to eliminate a source of information altogether so that you don't overwhelm the people who are responsible for being able to actually find and fix these high impact issues.
Yeah, that's a great question. Alert fatigue is actually one of the biggest problems that we've seen with data engineering teams. They're really overwhelmed with the large number of issues that are emerging. And oftentimes they're like, what do I do with this huge number of alerts? So a few things that could help. One is bringing these issues to where users already are. So that can mean, setting up Slack channels. So you get it within your workspace that you're actively participating in. And then two is some kind of categorization for those data incidents, whether it's like, incidents that are all related to a certain sets of table or incidents that are of a certain nature. They're all, pipeline delays, or they are all, field distribution issues. Categorizing them together so you have some sense of high level priority to know when you drill into this list of issues, they're all of a certain type and can have similar root causes. You can also send the similar category of incidents to the same channel to help you prioritize and organize the workflow for these incidents. The third would be assigning some kind of priority to help you tackle certain issues first and then being able to, sometimes ignore some of the other issues. So one thing that we've seen a lot of our customers do is marking the key tables that they have. If this is like a very high stake data set, we tag that as a key table. And whenever there's issue that surface with these table, we know that it takes priority over the others. And for some of these like higher priority incidents, you can also set reminders on these incidents. So if I miss it one time, I get another reminder until I fix it and update the status so it doesn't show up anymore. And for some of the lower priority incidents that are less time sensitive or lower stake, you can set up the notification in more of a digest format. So if there's a lot of schema changes that happen with my tables, and I don't necessarily care about every one of them, I just want to be aware of it at some point, then I can set up maybe like a daily or weekly digest. So I review it just once for this same type of issues at once, and you don't have to invest too much time into it. Yeah, so those are some of the best practices that we've seen our customers and a lot of the data engineering teams apply, helping improve the ability to prioritize workflow and reduce alert fatigue.
Yeah, I would add, I think that this idea of getting the right message or the right incident to the right person in the right place is like one of the things that our customers invest a lot of time in. It's a real kind of force multiplier, if you will. If you don't get that right, then the whole system effectively becomes useless. And I think as a kind of just like a rule of thumb, what we've seen work well is like if a customer is getting or an individual user is getting around 5 incidents a day, that's manageable. But once you get into 15, 20, 30 incidents in a day, it becomes effectively not manageable. And in the words of one of our success teams, like we would basically annihilate the customer and being able to actually address the issues. So we're really careful about that. We spend a lot of time thinking, how do we make sure our customers are being able to manage the workload of incidents that are being generated, that they are useful, that they are actionable. We're not inundating them with things that they can't handle. Some rules of thumb there, the 5 incidents is a really good one that we found to work really well.
Beyond just being able to say, this is a problem, this needs to be addressed, there's also the question of routing those notifications to the appropriate user at the appropriate time. So if it's an issue that is high impact, but you know that the batch job isn't going to run for another 24 hours, you don't necessarily need to page somebody at 3 a.m. Or, if the incident happens and, it's something deep in the code of the data ingest pipeline, you don't necessarily want to send that notification to a, BI engineer who's just writing the dashboards. So I'm curious how you've seen teams approach that question of alert routing, paging and notification, and just how you see them handling that kind of on-call rotation and alert delivery question.
Yeah, I can touch on that one. I'm curious what you think, May, too. Like the way that we structure it is we try and give customers as many levers and kind of slices on the incident feed as possible so that they can align with their internal organizational structure. So it's like if they do have an on-call rotation, to create a Slack channel where that on-call rotation person is responsible for the incidents that are flowing through that particular channel. And then we can do a lot of sub-filtering on top of that. So I think May mentioned the idea of filtering on a group of tables. So these, 150 tables, super high impact. I want anything that happens here to go to this particular Slack channel. And that's going to be higher in the priority list for that on-call person because they know, okay, yeah, those are the important tables. We even have one customer that they have like some financial data that's really important. It needs to be perfect. And I think they have a Slack channel dedicated that everyone knows. If there is an incident in this channel, like everyone stop what you're doing and go very quickly address that. So just that idea of filtering, making sure that you have instructions in kind of within Slack or whatever, kind of collaboration tool you use to be advised of those issues happening very quickly, and you know how to prioritize them. And then I think there's another one that we mentioned too, this idea of importance score. That's something that we can pass through. So we say this is a key asset. This table is super important based on a bunch of different factors we look at. We're helping customers look at that as a filtering mechanism for what they should be addressing or not. But yeah, I think those are some of the big ways that we've seen people figure out how to get messages to the right place and the right team. And then a lot of times individuals themselves are setting up notifications for areas that they're responsible for. So I want to get this email to me, or I actually just want to get a digest of what's happening. At the end of the day, tell me the 10 things that happen in these tables. I don't need to hear about them in real time.
Yeah, another interesting one I've seen is one of our customer PagerDuty. They have this team responsible for their data ops called the Data Duty for their high priority reports, like a few, executive report, financial reports. They actually set up PagerDuty themselves as the alerting mechanism, and they apply this escalation policy that goes from, data engineer to data engineering manager and all the way up to the executives when there's an issue with those high level, high priority reports, and to make sure that for these most important asset, they get alerts and reminders on it to the most important people until it's addressed.
And on that point of using some of these, what folks would view as DevOps tools that are primarily oriented towards application development and application operations, what have you seen as the applicability of systems such as PagerDuty or things like Sentry, or maybe more kind of generic application-oriented monitoring systems such as Prometheus and Grafana to the domain of data, and being able to feed those systems and integrate them with a Monte Carlo or some of the other more data observability-oriented tool chains to be able to have this holistic view of both the sort of performance and capacity of the underlying infrastructure layered in with the data domain and the kind of information modeling aspects of the problem space.
We have plenty of customers that actually use all the integrations you just mentioned. We also integrate with OpsGenie. I have seen some customers push data into Grafana. So the way we see it is we want to be agnostic to the actual tool that the teams use to manage the incident feed, to be able to address and make sure that we're integrating into whatever system they already currently use. We're huge proponents of people using what they already use to kind of get in front of the team and make sure that they're properly triaging and assigning issues out to everyone on the team. The additional piece that might be differentiated is the way we look at it is how do we actually help customers resolve the issue? And I think that's where we're making some investments to help people say, okay, what is the single pane of glass so that I can actually see all the different components that could be causing this issue, and making it easier for people instead of having to run around to all the different component systems to figure out, is it Airflow? Is it something in Snowflake? Is it something upstream in the raw data? Kind of where is that issue happening? Instead of having to run around, we say, here's a single pane of glass. Here are all the clues that we've been able to ingest to help you figure out where do I actually know where the root cause is happening. So that's the one place that some of the PagerDuties of the world, while incredible tools, it's harder to bring in that context. We're really excited about those types of integrations, and we have tons of customers using them.
To that point of being able to have that holistic view of, I have an issue, to now I'm able to identify the source of the issue, figure out the steps to resolution, and then indicate to the end user, this is resolved. Curious what you see as a common process and approach that an individual or a team might take to be able to bring that incident from, this is a new incident, we need to address it, through to resolution, and some of the kind of debugging tasks and the pieces of information that they need and the context that's required, and some of the ways that they might approach that as a new and developing data team who doesn't necessarily have the sophistication and all of the integrations in place, and then how that might differ with a team that has developed that muscle. They're more practiced at being able to handle incidents, and maybe they're already using a data observability platform or a data catalog to view that sort of lineage and impact graph.
data engineering teams that are a little bit more early on without the stack in place to, have an observability platform, have the lineage tools in place, it's a little bit scrappier. Oftentimes they, instead of, having a tool that gives them a one pane of glass view, they will go into the different operational systems. So for example, if there's a delay in updates for one of their table, they will have to go directly into their Snowflake to see, when it was last updated and who updated it and who are the users that are querying that table. If they need to investigate further, they will also look what query is, populating this table and what's the upstream table to this table. And they go one level upstream to see if there's any freshness issue into that. Then they will go into the external data source to see even further upstream if it's a API change resulted in the data being ingested, changing volume or changing update frequency. But for the teams that have more of a solution stack, they will be able to have one, pane of glass view. So for both investigating the root cause of an incident as well as, assessing whether they need to investigate the root cause of incident or they can ignore, it's easier for them to have an initial glance of, how many tables are impacted in this incident and, how many queries are run in these tables and what are the downstream BI reports that are associated with these tables and whether those reports actually have any engagement, have any adoptions or views with them that warrant, a investigation process. And then when they go into it, they're able to leverage, for example, lineage tool that they can use to see what tables and reports are downstream, as well as which tables are upstream. So they can quickly identify what could be a potential source of issue, depending on the type of incidents that they're faced with. For example, if there's a high percentage of null rate for one of their data field, oftentimes they will go into their data warehouse to pull those rows that have the null values and then see if these rows are attributed to a certain channel or if there's any clue that provide a reason for what could have resulted in these values. So those are the more common things that we see that teams have applied when, going through the process of investigating an issue.
So now your modern data stack is set up. How is everyone going to find the data they need and understand it? Select Star is a data discovery platform that automatically analyzes and documents your data. For every table in Select Star, you can find out where the data originated, which dashboards are built on top of it, who's using it in the company and how they're using it, all the way down to the SQL queries. Best of all, it's simple to set up and easy for both engineering and operations teams to use. With Select Star's data catalog, a single source of truth for your data is built in minutes, even across thousands of datasets. Try it out for free and double the length of your free trial at dataengineeringpodcast.com/selectstar. You'll also get a swag package when you continue on a paid plan. As far as the sort of more formalized incident management processes in the operations space, I've usually seen it where there's one person who is put in charge of actually resolving the incident and driving the remediation. There's another person who's there as the observer and the communicator, somebody who's responsible for taking notes so that all of that information can then be compiled into a post-mortem after the fact to be able to use as a feedback mechanism to fix and preemptively resolve these problems to keep them from happening in the future. And I'm curious how that plays out in this context of data teams, maybe if there are particular roles in the group that generally fall into one of those responsibilities during the incident, and just some of the communication aspects around data incidents and how they might differ from a operational context where you're not necessarily trying to fix a site being down and hemorrhaging millions of dollars in the event of a large e-commerce site, but you are trying to prevent a potentially very impactful and problematic issue with your data that can lead to these larger incidents, but maybe not have the exact same kind of timeliness component to it.
What we've seen a lot of times is history does repeat itself, unfortunately, in terms of when it comes to these data incidents. And I think to your point there of some of the incidents might have the same kind of urgency or potential impact, we still want to invest. And I think we're seeing customers want to understand what that issue is, because if it keeps coming up, even if it's just a nagging issue, teams want to be aware of those patterns and think, okay, how do we now like address that issue and stop that issue from happening in the future, even if it's small and easy to fix. There is a big piece of documentation there. So I would say not even the roles, but more about the like just kind of the mechanism that we have as a team to document when an issue occurs. I find this, on the product side, as a product manager, one thing that we love to do is a change log. So we want to know what has changed. And as a PM, if every week I have to figure out, okay, how am I going to capture the change log this week? Should I use a Google Doc? Should I go use some new tool? Should I try and put it into, a Jira ticket? I don't know. That kind of friction means that I probably won't do it. What we're trying to do is like, how do we reduce the friction and make it so that everyone knows, like, after an incident happens, this is the way you do a postmortem. And it's these three components, super clear. There's no question. And I think removing that friction is actually the most impactful thing that we can do to help teams get in the habit of doing these postmortems. Because the reality is, like, the postmortem is probably the least fun part of the actual resolution process. Like, it's exciting. I'm resolving the issue. I fixed it. Great. Hurrah. And now it's like, I don't want to spend time writing this down. So what we're thinking is like, how do we remove that friction? That's what I would say is the most important piece.
And then in terms of the additional components that are useful beyond just saying, okay, I have some signal that lets me know I have a problem, what are some of the additional capabilities or tools or automation or systems augmentations that they'll build in to be able to decrease the time to resolution so that they can find and fix problems more rapidly and be more proactive about identifying potential failures?
One thing that I've seen a lot of data teams either are working on building or are planning to invest time into is building this lineage tool. You can construct it with, a dbt tool or leverage other vendors, but also some teams are investing their internal data engineering resources to build that tool. And specifically, if you can invest to build a lineage tool that give you visibility into field level dependencies, that's even more powerful. Common use case we've seen from customers are they want to deprecate a column, want to know what are the downstream dependency, what are the reports that will break based on that change, as well as if there is a specific issue with a field in a report, how do we track down, which field upstream is the source of that anomaly. Using a tool like field level lineage is something that will be able to power those use cases. A shameless plug, we actually built this tool at Monte Carlo, and a couple of my engineering colleagues and I recently published an article about how you can build a field lineage tool on InfoIQ. Happy to share the link if folks are interested in.
Another practical thing that I've seen teams do, especially if they're writing tests in a SQL-based environment. So let's say I want to write a SQL command that checks for a particular field always being not null. The thing that I've seen people do is to write the test, but also to include within the test all of the other columns within that table. So when the test runs, basically, yes, it's checking for the nullness of that particular column. But in addition, we're pulling in the context of like those null values, what other field values exist within that particular set of records. And we've seen people do that with our SQL rules tool. I think that can be done within like a great expectations environment, even dbt tests. So I think that idea of like when you're writing a test, how do you think about the context that will be helpful when you now need to resolve that issue that's been caught by the test? I've seen that to be really effective as a kind of another simple hack, not very complicated, but simple.
Once you have resolved an incident, one of the things that you mentioned as some of the post-resolution steps is running backfills. And I know that that can be challenging if you haven't already planned that in when you're designing the initial pipeline. And so I'm wondering if you can talk to some of the considerations and strategies that are necessary as you're designing and building out these pipelines in the first place to be able to properly handle backfill operations for the case where you do have a problem, you do need to regenerate the data, and you don't want to introduce new problems as a result of trying to fix the old problem.
Yeah, this is a tricky one. Yeah, I think as a PM, I probably am not the most qualified. Maybe May has some better ideas here. But one thing that I've seen, I came from a world from Segment, which was all about streaming. And the idea of like backfilling data was nearly impossible. It was kind of like a one-way stream of events. And once those events were pushed into a destination, it was very difficult to undo any of that. But I do think from like, at least from what I've heard, is this idea of like understanding to build the pipelines with some kind of like temp tables in between so that you can do some rollbacks. Like there's a lot of things that I think we've heard customers doing. I will be the first to say I'm not the expert in that. I don't know, May, if you have additional thoughts.
not super familiar with like best practices around this. We'll hear if, Tobias, you have any ideas around that.
So, I mean, definitely one of the things related to backfilling is that it's usually related to working with batch data sets and dealing with blocks of time. And so in my own work, I've got one pipeline, for example, that the way that it's written, it runs on a daily basis, but the code itself is kind of naive to the timeliness of the data. It will just run a SQL query, dump out whatever the contents of the database are at that point in time. And so if you try to run a backfill to say, oh, I missed 5 days worth of data, I need to fill in those 5 days, it's not actually going to fill in that missing 5 days worth of data. It's just going to generate whatever new data it happens to have available. And so as you're designing the job, you need to be thinking about that sort of time window aspect of it. So when you're writing the queries, you want to make sure that you are passing in specific date ranges so that you're only selecting and working with the data that is pertinent to that specific window of time. And that gives you also the flexibility of being able to adapt that same task for different granularities, where you can say, okay, I care about being able to populate this downstream system with information on a daily basis, this other system, or for this other task, I actually care more about the weekly or the monthly aggregates. And then because you already have information about those time windows, when you need to do a backfill, you can just generate the appropriate time windows for those windows that you missed, and you don't have to be concerned about saying, okay, well, actually, I'm pulling in the most recent data, not the older data. And so just as you're designing the pipelines upfront, understanding that backfilling is something that will have to happen no matter how careful you are. And so being very deliberate about having time and windowing be a first-class consideration in all of the jobs that you're building.
Yeah, no, I've seen also the idea of adding pending columns with the timestamp at the time at which the data arrived. I think that's another thing that I've seen work well. So it's like, to your point about time, understanding which different timestamps you have for when the event was received, potentially, when it was pushed into the actual warehouse, when it was potentially removed or ETL'd or ELT'd. Those are also, I think, considerations I've seen work well with my limited experience there.
Yeah. And in the event that you're working with, for instance, a set of tables that don't have any conception of time, there's no date time column in there for you to be able to segment across. Another option is being able to use some extra maybe key value system to be able to say, okay, in this batch, I processed these IDs, this range of IDs from this database table. And so then in your job definition, you can say, okay, when I need to backfill, I'm going to query this key value store to see what are the IDs that I've already processed, and then query against, what are the gaps to say, okay, I only want to process the IDs that I haven't already worked on. And so that way you're making sure you're not duplicating effort. Another question that's interesting to dig into in this space of incident management, incident resolution, and kind of the organizational technical practices around it is, in your experience of working with your customers and the various teams that they're involved with, what are some of the sort of gaps in experience or knowledge or understanding that you've encountered that have been useful to address as you're helping them adopt these practices of incident management, data observability, and just kind of the raising the general awareness of how to approach it and the relative importance of having that capability in the team?
The one thing that comes to mind there is just like even the concept of SLAs, SLOs and SLIs, which I think in the software engineering world is fairly standard in terms of probably have a good understanding of that measurement model. And I've had many conversations with folks in the data world that have never heard of that before. And, obviously there's no fault of their own. I think data engineers that we speak to a lot of times are focused on the hair on fire problem of like, oh, I have, spend most of my day trying to respond to consumers or data consumers saying something is wrong. I don't have time to go research best practices in the DevOps world. So I think just that concept of like defining what an SLI is and then being able to have some kind of objectives that you set as a team and then an agreement, which is kind of the holy grail, I think. That's an exciting area. Another one is severity levels. That's, again, a similarly standard practice in the DevOps SRE world. If this is a Sev 1, Sev 0, Sev 2. Similarly, not a common practice among data teams, at least many of the ones that we've spoken to. Yes, there are many that do think about the world that way, but I would say the majority of folks don't yet think about it that way. So I think those are just really helpful things that we can borrow from the DevOps world and keep in mind as we build out systems for data, which I will also note is significantly more complicated. I think we've touched on that multiple times here, but there's a lot additional complexity to building an SRE or DevOps system for data. But I guess that's why we're here. It's exciting.
In your work with these teams, what are some of the most interesting or innovative or unexpected ways that you've seen them approach this overall problem of incident response and media and mitigation?
I think there's one example that comes to mind. We have one customer that they became really obsessed with this idea of wanting to classify every incident that Monte Carlo generated. And we have a mechanism that you can classify things as investigating or resolved or not an actual issue or even false positive, where there's an actual issue with the underlying detector logic itself. Those are really helpful signals for us. But what this customer was, they were like, I want us to basically classify every single incident that comes through. He actually went and built a Slack bot that would remind people and kind of like chase people down if an incident wasn't classified. So I think people were just getting inundated with like, you didn't classify the incident. It's like, okay, I'll get to it. That one was pretty interesting and innovative. And then there's another one that one customer that I've been talking to, they happen to have a lot of sprawl. So like in the hundreds of thousands of tables. And they kind of, I alluded to this at the very beginning, but this idea of how do we think about like simplifying this? How do we reduce the complexity of this? And this is like a next level type of analysis of the problem. This particular customer was like basically using our lineage nodes to kind of like compute a complexity score for all the different schemas that existed within their warehouse. And then being able to then use that as a prioritization model. So say like, okay, this is super complicated. What are like the ways that I could potentially reduce the complexity by removing tables that aren't being used or that have been around for eons and then no one knows what they do? But anytime that this person would try and go and say, I want to go remove this table because I don't think anyone's using it, they were like, if I do this though, I'm responsible for the kind of ensuing pain that could be caused by that. So it's just like a really innovative approach to thinking. Like you could even think about the process, or I could think about reducing the complexity so that when I do build a process, it's actually going to work. I thought that was a really interesting perspective and really like pushing the bounds of what's possible. Like there's not easy ways to, build a graph database on top of lineage today, especially when you have hundreds of thousands of tables. And one that could even be comprehensible. Like as a human, obviously I can't store 150,000 things in my head and look at a graph and understand it. Maybe some folks can. I certainly can't. But anyways, that's I think another example of an interesting thing that we've seen customers do.
Yeah, another one that I've seen is a data engineer building a visual pipeline of their entire data flow. This task is upstream of this other task. And if it's running, an hour late, then it has downstream dependency on all these other tasks downstream of that. Completely visualize that and being able to, pinpoint to one and see the impact of that one text on all the other pipeline that have dependency on it is a super cool internal tool that I've seen. Another one I've seen is data engineering teams being creative with the way that they tag assets. So one company actually parsed their own DBT model and use the parsed artifacts to determine whether this table is important or not, and then assign those key asset tags to those tables and use that to route the incident alert to other teams. So it's a hacky way to reduce noise, the amount of incidents that they're receiving, and help surface some of the most important issues for their teams to focus on.
And in your own experience of working with these teams and helping to understand the overall process of incident management, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
I think the interesting thing that I've seen in the space is that collectively, all the teams are exploring the best practices going forward. Since it is a new paradigm that we are building, every team is eager to learn the best practices that other teams are exploring and try to, pick up things that they could apply from other companies. We oftentimes hear customers asking, oh, how are your other customers using field lineage? How are your other customers using the routing the alerts to, make sure that the right team gets the right incidents? So I think it's like the collaborative effort and eagerness to, learn from across team that's interesting in this space.
I was going to say, I think one of the more interesting lessons is just the importance of notification fatigue. I know we touched on that for quite a bit earlier in the podcast, but the idea of like not sending too many messages, I wouldn't have thought that that would be just so important. And like there is this very clear threshold after which the notifications lose all value. So I think that was one of the most unexpected things, I think, in the work that we've done with our customers and just coming to that realization of how important and critical this is.
And for data teams who are just starting down this path of starting to work with incident management, or if they have reached a certain level of sophistication, what do you see as the missing pieces of being able to help them identify and resolve problems as fast as possible, and some of the either principles and practices that need to be popularized among the data ecosystem, or new technical capabilities or integrations into existing systems to make this a simpler problem to adapt and solve?
Yeah, I think the incident catching process, identification, and notification process has pretty much been built out. Different vendors, different tools in the space. But what's really still missing, just given the complexity of the issues that could happen, is the root cause analysis piece. Because it could be, all kinds of variety of, external systems that data engineering teams deploy. It could also be, all kinds of variety of type of issues like a code change or, a data pipeline failure, or like a humongous number of types of data sources, format change, type of data change, values change that can result in these incidents. So there hasn't been really any automated solution to help teams resolve or identify clues that can help them resolve these issues fast. So I think that's the main missing piece in the stack today.
I'd add the piece of understanding deeply the downstream consumers. And I think given that data is proliferating across organizations, everyone's talking about how, all these folks within the organization are actually using data to do their job. The question of okay, the fact that this particular table is broken and not being able to deeply understand exactly who in the organization is being impacted by that I think continues to be a big gap for us. And we've spent a lot of time, we actually have quite a few tools to start understanding, which downstream BI dashboards, who was looking at those dashboards. But that extends further. It's which data scientist potentially ran a model on that particular data? And did that model have an output that was then used by the customer success team to, address a particular customer or sales folk to actually go out and reach out to a prospect because this model had this output based on the bad data? So it's what is the ripple effect of data being proliferated and these decisions being made across the organization? So just mapping that out, I think, is a huge opportunity. What actually happened? Who was impacted by this? It reminds me, one of our customers said, the fact that they don't have that means that as a data engineering team, anytime something happens, they basically have to notify half the company that something broke. Whether or not any of those people were impacted by it, they're still saying hey, just this thing happened. We're able to address it, but there's this potential ramification of the data having been broken for this amount of time. And that's just an incredibly painful thing to do as a team. So imagine having to just constantly tell the whole org, hey, this thing messed up. This thing messed up again. You're just kind of eroding the trust that you built with the organization as a data team. So I think, we really want to be able to help customers narrow down who was impacted by this and only tell those people that there's this potential thing that happened and this is what you should do as a result. There's a huge value there, I think, that we can create, and I think is a gap today.
Are there any other aspects to the overall space of incident management and how it manifests for data teams and in data platforms that we didn't discuss yet that you'd like to cover before we close out the show?
There's one that we hear a lot, and it's this idea of going back to the reducing the complexity, just being able to quantify and map data that is not being used. So which tables has no one looked at? That simple question is actually, it might be easy to figure out, but we find that it's not something that data engineers are necessarily doing on their own. So I think that continues to be an area of how can we reduce the entropy that is occurring within our data systems versus continuing to allow kind of anyone to create any table anywhere in this kind of common data warehouse that everyone can access. What we're seeing is the need to create more structure and control so that the proliferation of schemas that, every single person that joins creates a new schema under their name. They might be having tables in there that are populating core downstream processes, even though it's in their own user namespace schema. That person then leaves the company, and then what do you say? Can I just delete this schema or no? Is it potentially going to cause a catastrophic failure down the pipeline? So I think just that idea of defining really clear practices of like, how do we as data teams ensure that people are kind of stewarding data in the right way is also a really exciting area for all of us. And I think from what I'm talking to customers, it's like feels pretty early, but also really exciting. That would be it for me.
Well, for anybody who wants to get in touch with either of you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question for each of you, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
The ability to kind of query and quantify the complexity of a lineage graph and slice and dice what is actually happening within lineage across the end-to-end pipeline from, raw data ingest all the way through, if you have a data lake, all the way through to the warehouse, all the way down to the actual BI layer, and just being able to understand all of the different relationships across each of the nodes within each of those subsystems and how they all work together. That's an area that we're making good progress towards, but it continues to be a gap. There's tons of opportunity within that. And once that's mapped, there's like endless possibility in my mind.
Yeah, as I mentioned, I think the incident management, most of the, anomaly detection, like the notifying teams and some of the workflow kickoff in dealing with the incidents has already been built out. And the piece that is really missing is the root cause analysis piece. And talked about it already, same response.
Well, thank you both very much for taking the time today to join me and share your experiences of working with teams to help them adopt and implement incident management practices and helping them understand how to manage better data uptime. So I appreciate all of the time and effort you've put into that, and I hope you enjoy the rest of your day.
Thanks so much, Tobias. This was a really, really fun conversation. Yeah, and looking forward to continue to learn from you.
Yeah, thanks for the insights on, backfilling data as well.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.